All right, in problems 3 and 4 in section 12.5, we're going to talk about what are known as work problems. And so reading 3, it says, one farmer harvests his barley in 14 days, the second farmer harvests the same crop in 12 days. How many days will it take them working together? And the key here to one of these work problems is to look at the rates, in this case, of our farmers. So the rate of the first farmer would be one crop harvested per 14 days. And then the rate of the second farmer would be that same crop, but now per 12 days. And if they're going to work together, then the key here is that the rates will add. Okay, so their overall rate is going to be the sum of their individual rates. Okay, so in other words, I'm going to have 1/14 plus the 1/12. I'm just dropping the units for the moment. And then I'm adding these together to get the overall rate, which is going to be, well, that same crop per some number of days. That's our unknown, so I'll call that x. So x days. Okay, so this is our equation, and then to solve it, let's go ahead and multiply both sides by the LCD. And now for 12 and 14, 84 is the smallest number that both 12 and 14 go into evenly. And then I'm also going to need an x, so I'm going to multiply now both sides of our equation by 84x. So here and here. And so now we'll go ahead and get the 84x to distribute. And 84x times 1/14, well, 84 divided by 14 is 6. This would be 6x. And then plus 84x times 1/12. 84 divided by 12 is 7, so this would be a 7x. And then over on the right side, notice the x's are going to cancel out. And so I'm just going to be left with an 84 there. Okay, so I get 13x is equal to 84. So dividing, I'm going to get x is equal to 84 divided by 13, which comes out to be roughly about 6.46. Okay, so our final answer here would be 6.46 days. Okay, and remember when you're working on your WebAssign homework, be looking for specifications on exactly how they want you to round. And if they don't specify, round to a certain number of decimal places, then it's going to be safe to assume just to put in this exact fractional answer. Okay, but it's very sensitive. Of course, just send me a message if you feel like you're having the system mark you down for something like a rounding error. Okay. All right, so now question 4 is essentially the same as this one, so you may want to pause the video and work through it on your own. It says one door can clear the theater in 9 minutes, a second door can clear the theater in 6 minutes. How fast can the theater be emptied if both doors are available? Okay, so go ahead and pull up our solution here. So again, we're going to just look at the rates of each individual door. So one theater per 9 minutes for door 1, one theater per 6 minutes for door 2, and then we're going to go ahead and add those individual rates to get the overall rate, and that's going to be one theater per X number of minutes. So we solve this equation. Again, I'm using the LCD. In this case, that would be 18x. And so then just distributing, we're going to get 2x and 3x on the left and just 18 on the right. And then that's going to lead us to this solution that x is 18/5, which is equivalent to 3.6 minutes. Okay, great. That's going to do it for this problem. Thanks.